Hello, and thank you for joining us. It's my pleasure to welcome you to today's exciting webinar, The Future of Data and Connected Vehicles. My name is Roberta Gamble, and I'm a Partner and Vice President here at Frost & Sullivan, and today I'll be your moderator, as well as giving you some insights on the topic. Before we get started, I have a couple housekeeping issues I'd like to go over. Throughout today's discussion, you can submit questions at any time, and we definitely encourage you to do so. Just type your question in the Ask a Question box on the left-hand side of your screen, then click Send. If you're experiencing any problems with the program, you can press F5 on your keyboard, and that will refresh your console, or you can close and relaunch the presentation. If you're still having any troubles, you can consult the Help tab, which is at the top right of your screen for tech support. We will be live tweeting during today's webinar. You can follow the conversation with the handle at @FS_events. And lastly, today's program will also be available on demand, and we definitely encourage you to join and to visit it and share it. You can find today's program at www.frost.com/Future of Data Connected Vehicles. As I said, please feel free to share your program with your colleagues. Great. Now moving on to today, we have a fantastic webinar with some wonderful guests. I said again myself, Roberta Gamble. We have Kenichi Murata, who is the President and Chairman of AECC and a Fellow of a Connected Company at Toyota Motor Corporation. We have Christer Boberg, Director at AECC and IoT and Cloud Technology Strategies Director for Ericsson, and Roger Berg, also Director at AECC and a Vice President at the Denso Corporation. Thank you all for joining me today. Right, so before we get started on the questions and the conversation, I wanted to take a moment to talk a little bit about what we mean when we look at the quantified motorist and connected vehicles. We're seeing data and information really streaming in across a number of sources that are going to be, as well as the vehicle itself, that are going to be interacting with vehicles. We're going to see vehicles interacting with other vehicles, interacting with infrastructure, of course, with the drivers and the passengers. We see data coming in from road conditions. We look at things like the amount of the car that's being driven, where it's being driven, how it's being driven. We look at metrics that have to do with consumer trends as well as the car's health and how it's being used. So as we move towards autonomous and other advanced systems in a vehicle, we're going to find that the upload speeds of this information is going to be really critical. You're going to have huge amounts of data that need to go, again, to other vehicles, to the infrastructure, and they're going to be using the cloud, they're going to be using edge analytics, and we have to make sure that there aren't gaps in the data that's being transmitted and used, what's being generated, how it's being connected. So low latency, massive bandwidth capability, and improved processing capacity are going to be the main advantages that we're going to see from 5G and autonomous vehicles. Additionally, MNOs are going to need to adopt predictive analytics to anticipate and manage outages, since that's going to have a lot of important repercussions for safety and usability of vehicles in the future. We see a lot of really exciting technical advantages coming into the automotive industry, and as you can see on the chart in front of you right now, the importance of latency and bandwidth is affected by the types of capabilities that we want to be able to engage. So whether we're talking about vehicle-to-vehicle services or telemetrics or teleoperated driving, even virtual reality, disaster alerts, so on and so forth, all of these features that we're starting to use and will continue to augment the driving vehicle experience are going to be very, very critical to ensure that we have that, again, that connectivity to be able to use these solutions. So real quick, we're going to have polling questions, kind of quiz questions throughout the session, and we're going to give everybody about a minute or so to answer these questions, and then we'll reveal the answer of what the experts across Frost & Sullivan believe are going to, and as well as in our conversations with AECC, what these experts expect the market to look like in the future. So our first polling question today is, how much connected car data is expected to be generated by 2025? You can see the answers here. It should be popping up on your screen. Are 50 megabytes per hour per car, 500 megabytes per hour per car, 1 gigabyte per hour per car, or 100 gigabytes per hour per car expected to be generated by the connected car in 2025? So we'll give everyone a couple seconds there. Just a moment longer, make sure everybody gets their answer in, and then we'll reveal what our experts believe to be what we expect. So actually, it's D. 100 gigabytes per hour per car are expected to be generated by 2025. So that sounds like a lot of information, but again, if you think about all the solutions that we're starting to use and expect to use in the future, that's really going to have a big impact on the market. All right, so let's now move into our first question and discuss with our speakers today. So for today's first discussion question is, what are the biggest opportunities out there right now in the connected vehicle space? And also, what are the biggest challenges? So who would like to kick us off on that question?
Yeah, maybe I should pull up the question.
Great, thank you, Madison.
Yeah, I think the question comes from the what is the biggest challenge, even though that the connected vehicle is widely spreading in the world, and as you can tell in the first polling questions, the data generated in the vehicle is getting more and more than before. Because of the vehicle is now composed of many electric devices and the software running on that. So the data is generated more than 100 gigabytes per hour per vehicle. That sometimes exceeds more if we take the more cameras on the vehicle. So how much data we can leverage for the purpose of collecting the automated driving vehicles or exchange that kind of data with other vehicles. That is fantastic things we can achieve with that kind of conditions. And then that's a good challenge in terms of the business point of view, I think. So biggest opportunity is by leveraging that kind of a huge amount of data, we can make a much more better services for the drivers or passengers or the other vehicles drivers or even for the residential people surrounding in that kind of loading areas. So that's a good challenge for the future, I think.
Great.
But there are tons of biggest, big challenges we need to overcome.
Absolutely, absolutely. Roger, any thoughts on this first question, or Krister?
Yeah, this is Roger. I'll chime in here. I think in terms of the opportunities, one of the biggest ones is really the enhancement of highly automated vehicles in dense urban environments, perhaps. And what this data exchange can do is really enhance the so-called operational domain, because under certain conditions if we can give reliable and low latency reliable information that might be detected by sensors either in the transportation system or detected by sensors in other vehicles. If we can give that sensor information to the highly automated vehicle's perception engine, we can really extend that operational domain for the automated vehicle, and we can use that data to predict the other road user trajectories and really enhance the safety of the system beyond the autonomous sensor suite on the highly automated and connected vehicle. So that awareness and information exchange about the surroundings operating around that highly automated vehicle and even an extended range, so that they can use those predictions to make evasive or higher safety maneuvers and reduce the probability of crashes with either other vehicles or other vulnerable road users like cyclists or pedestrians. So if you think about that, the challenges in doing something like that are pretty apparent. Like, what kind of data is transferred between the sources and the users? How and where within the network between these endpoints, the producer and the user, will the necessary processing be done? Will it need to stay in the vehicle? Will it need to be in the immediate regional cloud device? Will it go all the way in the immediate region edge device, or will it go all the way back to the cloud? Do we have time to do that under every operating condition imaginable? And how do we ensure that the availability and reliability of this data, and where is the best source? So in some cases it might be a neighboring car. In some cases it might be a traffic intersection a mile ahead. So where do we get this data from, and how is it used by this highly automated vehicles? Really a question that we need to answer. And to be honest, the teams within the AECC are trying to address these types of use cases and really looking at the appropriate technical solutions where we can get these questions answered. And this includes, computational partitioning, like I mentioned. Is it done in the car? Is it done in the edge? Is it done in the cloud? And really distributed edge computing as these cars are moving around from city block to city block or around corners.
So it's kind of developing this matrix of information across the system.
Exactly.
Not just that's fascinating. Good stuff. Christopher, any initial thoughts before we move on?
Thank you, Roberta. No, I think my colleagues Murat-san and Roger gave a great introduction to the opportunities and challenges, and I can probably just add and emphasize on the fact that if this should happen, I mean, there are things to be considered, and not the least when we look at bringing all this data from the vehicle to the cloud, that we need what we call coverage. It must be possible to send data not only at certain points but continuously. So that would require improved coverage, and in general that you have access to the network on all roads basically where you drive a car. Then, as Roger mentioned, you need to look at how can you have improved latency, how can you control latency for traffic, and just the topic that we work very much on in AECC, the data, and how can we keep what we call the service experience while reducing the amount of data that is sent possible, and those things that we do with edge computing, etc., are key for that to happen. And then there are challenges when it comes to the business situation as such, including existing solutions such as roaming models and how you actually handle these type of data amounts in those environments. So beyond that, then of course, when we build things and provide things that it's interoperable, that this is globally available for the automotive industry to utilize. So those are some additions I would just want to make.
Great. No, thank you for that. And if you think about any challenge that you might have today, just downloading a video, moving, in roaming or moving to a different section, that's going to have a lot more importance in the future if your vehicle is depending on that. So what can you move to the edge? Yes, that's great. Thank you. Thank you all for those great comments. All right, let's move on now to our second polling question. Do you want to keep this interactive? So for our second question, what do you think experts project the global connected car market is going to be worth by 2025? So what's the size of the market in terms of revenues? Are we looking at it being about a $52 billion market? Are we looking at an up to $120 billion market? Do we expect it to be a $168 billion market? Or might it be as much as a $254 billion market in 2025? So we'll give everyone a moment there. What do experts project the global connected car market will be worth in 2025? Okay, now we'll move on to the answer. And it's expected to be up to $168 billion. So that's a pretty significant market size that we're looking at in the future. Pretty big market there. Okay, great. Let's move on to our next question then. So what is the role of edge computing in making connected vehicle services a reality? So good question here. Krista, you mentioned a little bit about edge computing in your response. Actually, everyone did. But what role does edge computing have going forward in the connected vehicles market? Roger, you want to answer that one?
Oh, sure. And I think it extends kind of on the information I talked about just a minute or two ago. Really, when you think about those scenarios, the amount of data that needs to be exchanged between the players in kind of an intelligent, connected, highly automated vehicle system is really huge. I think Murata-san mentioned that earlier. And I think the other important point is that almost all of the players in that data exchange will create or consume, or both, all this data under these conditions, and they'll be really highly mobile. I mean, even if you're in a dense urban area where you might have, a number of microcells just to get the capacity for the data exchange in these dense environments, really you need to provide service levels. And if you're talking about this need for high reliability and low latency information exchange, really the different service entities that will be providing the exchange of that information, the processing of that information, will be required during a highly automated vehicle journey through perhaps many of these different microcells. So kind of put forth an architecture that will enable those kinds of services that are highly mobile but at the same time low latency and high reliability. People at AECC are developing kind of what we might call a system of systems rather than a single ecosystem. And really that's made up of the computing infrastructure services, whether that's on the cloud or in the edge, and probably in these high reliability, low latency information exchanges. You'll see more of this closer to the action of the services that need to be rendered. And part of that system of systems is the access network and the gateway networks to really distribute that information to the proper, mobility service and the proper computational entities that are that have the availability and the bandwidth to action this data. And really, we see in an environment where we're trying to improve the safety, and it's a mixture of these highly automated vehicles that I'm talking about and really human piloted vehicles that may not have that data collection. We can depend on perhaps some infrastructure sensors that can add the predictive capabilities of these unequipped vehicles towards this kind of system-wide awareness that enhances the safety of the operation for both the computer-driven or the highly automated vehicles and those that are driven by humans. And really this distribution of this intelligence in this heterogeneous system really will likely be decentralized and distributed between these service centers, between the entities participating. It could be the vehicle processing, it could be the edge processing, it could be the data center or the cloud processing. And really the optimum manner to do that is what we're studying in AECC and architecting solutions to be able to achieve those use case key performance indicators that allow services like this to be rendered in this heterogeneous environment.
Right. So yeah, so system of systems, it sounds like in a couple different ways, in the sense that you're talking about the edge, you're talking about the cloud, you're talking about the network, but you're also talking about sensors that help less modern vehicles, because we're not going to in 2025 suddenly, we're going to have a real mix,
Right.
aren't we, of modern and less modern vehicles, especially in certain regions. So having to be able to integrate that so everything works smoothly. Great.
Yeah, it's a interesting problem for technologists, but I think it has a social impact as well, because it's really about the safety of the transportation system in a widely varying operational domain. So I think obtaining information from these sensor systems and exchanging that information is really key to keeping that kind of environment safe and efficient.
Right. Okay. Great.
Yeah, and
Great.
also that kind of the data collected from the connected vehicles would be usable for the area of the connected vehicles running around. The vehicle's data of the data of the connected vehicle running in London is nothing related to the data of the connected vehicle running in New York City at all. So that the data collected in London should be consumed in London, and the data collected in New York City should be consumed with the data of the other connected vehicle running in New York City, So that's a kind of a locality exists, and also the kind of data could be compared or analyzed with the other data of the road sensors or climate information data locally. So that kind of data computation locality would be exist, and that kind of the analytics of the data of upstreaming data locally would be a kind of a new era of computation and data exchange, I think. So the connected vehicles data is a kind of a leading edge the services using that kind of a new era, I think.
Christer, just to emphasize on that, maybe we should also just state that this is one of the key aspects that we work on in ASSC, and we have invented a concept we call distributed computing on localized network to handle exactly what was stated by Roger and Murata-san here.
Okay, thank you. Thank you for those insights. Appreciate that from everyone. It's a great question. So moving on to our next polling question, third one. How many connected passenger vehicles are expected to be on the road by 2025? So we've already asked how much data is expected to be generated. We've asked how big the market is. But how many vehicles are actually expected to be on the road? And again, not all the vehicles on the road will be connected. So it's important to understand how they're going to work together in a localized fashion for safety and efficiency. So our first response here is A, 50 to 100 million, B, 150 to 250 million, C, 300 to 400 million, or D, over 400 million connected passenger vehicles expected on the road by 2025. We'll give everyone about a minute there to put in their answer, their guess or their calculation. Wait another moment. Okay, so let's reveal the answer. And the number of expected connected passenger vehicles on the road by 2025 is expected to be over 400 million. That's a huge number. I don't know, Murata-san, do you have any thoughts on, what proportion of the total vehicles will that be within a few years here?
Yes. So the 400 million vehicles, can you imagine how much vehicle of the percentage of the running vehicle in this road? I'm not quite sure, but in our cases, Toyota's cases, we already start to see the connected vehicle, almost all the vehicles in U.S. cases, for example. So that if you count the number of the ratio in 2025, that would be more than 75% of the vehicle in the market would be the connected vehicle, I think, at the time.
Wow. Okay, so about 3/4 of the vehicles on the road by then will be connected. Great. So that leads into our next question then. So what kind of connected vehicle services can take advantage of distributed edge computing? So we just asked, earlier what the role of edge computing was. Clearly, there's a very strong role for it. But what kind of services are going to take advantage of that?
Well, so as I said, the main reason why we take this kind of distributed computing is to collect the data locally and to analyze the data with other vehicles' data locally. So that kind of a service would be the best fit with the distributed edge computing, such as, for example, let's see, the data observed the road conditions by the camera image data of each vehicle as gathered, and also some the tire rotation speed or slipping sensors that would be generated to the local cloud, local distributed edge cloud, and then if we make some analytics of those kinds of collected data, then we may be able to find out, this road is this location is a slippy conditions, and or this is the big hole would be on the road. We can observe, or that kind of things is pretty much good for fixing the road face or road surface, or avoid make some caution to the drivers, or that kind of safety service would be achieved. So that's just for the safety services for the drivers, but also we can make much more business using that kind of data back to the driver or passengers of the vehicles, or maybe some other type of the services for the other people out of the vehicle as well. So that's new connected vehicle services, I think.
Okay, so the localized safety information like we talked about, but then also maybe some value chain partners or some additional revenue generating services that could use edge architecture to really come to life.
Right. That's if we can collect that kind of data from 400 million vehicles,
sure,
we can make any kinds of services with that, I think.
Absolutely. That's a great point. That's a lot of data to process. Absolutely. All right, great. Thank you. So as we look forward, how can MNOs, OEMs, and cloud solution providers work together to drive the future of the connected vehicle? Because as we've talked about a lot today already, it's a matrix. There's a mix of connected and less connected vehicles on the road. There's a lot of connected vehicles on the road. We're looking at these challenges of connectivity and edge use, but also a lot of opportunity. So I imagine there has to be a lot of collaboration in the future. How can these companies work together?
Yeah, Christian, maybe I can start on that one.
Great.
So, I mean, if we look at the topic we have at hand and what we have discussed here in this panel, it is important to start with what we call global consistency, because when we look at the connected vehicle and the automotive industry in general, it's a what we call truly global industry, meaning that when we invent and propose solution, it has to be available in a timely fashion on the right scale, meaning that functionalities cannot just be proposed and then implemented on a regional or local base. At least for some time it could be possible, but the whole point here is that when we work together on what we call end-to-end, we do have the possibility with these players, including the OEMs as such, the tier ones providing technology to the cars, the mobile network operators, the telco vendors, network vendors, cloud players, and application providers, that we can agree on models and what we call standard blueprints, meaning that we decide that this is the model we want to use, and we can identify gaps, and we can also, when needed, drive standardization to fill these gaps. So that is key, that we get all the actors end to end involved. And that is tricky, because that also means that there are certain functions and mechanisms that must be available, and these then must be commonly accepted, and it should be as much as possible what we call cross-vendor and provider agnostic, so that any player, any OEM, any application can use any infrastructure, any network from different vendors and service providers. It cannot be what we call a lock-in effect. It has to be available. So, but as Murat-san also mentioned in the previous question, I think that's very interesting, because Murat-san talks, of course, from his company view and the Toyota view, meaning that there is a value of innovation when, first of all players come in the chain, work together, but that there is a certain problem domain that is owned by an actor, such as in this case Toyota, which have real use cases in mind to be solved, and I have identified issues. And that is sort of why AECC started from the beginning. So it has a high value and the probability of success. First of all, when you have an owner, or say a requester for a certain problem, but when we have the full ecosystem from the car to the cloud, so to say, and everything in between to solve these problems. That is what I believe is the main task for us to solve here together.
Sure, rather than a go-it-alone approach, to create that, I don't want to say platform, but create that system or that common ground, help develop that common ground so that these different players can come together and really create this future for the connected vehicle.
Yeah, and actually really work on a real problem, and maybe not only something that you think could be a problem, but something that actually has a business value. I think that's high value.
Right. Actually tackling the real challenges and not just something that's hypothetical or speculative. Great.
Right.
Good. Thank you. Great. That's great to hear. So we were talking about the importance of the AECC coming in and creating this space or this opportunity for different types, whether it's OEMs, mobile network operators, and so forth, to really solve the challenges of the connected vehicle and make it a reality. How does the AECC help companies develop proof of concept around connected vehicle services? So how does that actually done? Who would like to take that first?
This is Roger. I can start.
Great, thanks.
I did want to add something on to what Christer was mentioning about the the collaboration effect of all the entities, and I think in the AECC, at least in my experience, I've seen a level of trust and intimacy between the members, that they trust each other's technical judgment, and they really try to listen and understand the real sense of the where the use case is coming from and why is it important. And I think that lends itself towards stronger and more robust technical solutions, which leads to now this question about, you can write a solution on paper and you can discuss a lot of things in conference rooms, but really when the rubber meets the road, it's about, does this solution work, and can you demonstrate that the solution that you've come to can actually achieve the objectives of the requirements of the use case, specific use case, or the categories of use cases. And so in AECC, we've developed essentially two processes that we have in place currently. One really is more traditional, system engineering approach, where we identify some requirements of a use case that has been dreamt up in the annals of Toyota or GM or Ford or Volkswagen or whoever, and they have a set of like user behaviors and what the user wants, and they translate this into more or less technical requirements, where the user group actually in AECC puts together a formalized document calling it a use case document, and they send it through almost along like I said, the traditional system engineering process to the specialists in these kind of technical solutions, where they can also take these requirements and dream up these architectures that they think have a good probability or 100% probability of achieving those key performance requirements. And then these teams work together to ensure that they understand each other's perspective. The technical people really deeply understand the use case, and as I mentioned, not just what, but why is that important. And the use case people really try to translate the requirements of the user itself in a more human terms, help create or define those requirements from a technical perspective, so that those use case requirements can be made. And once that's done, then we start to work with other member companies who actually have implemented or can implement these kinds of solutions that are recommended by the technical design team, and we can show and demonstrate that those use case objectives are actually made in a demonstration or in a field test. So we call that first process really a top-down, what we call top-down. So more, traditional systems engineering, more traditional, committee led process, and it translates from the use case to the technical requirements to the actual implementation, and then in essence a kind of circular flow is built. So the implementation says, well, we can achieve all these things, but maybe not one of them. So it goes back to the use case, and it kind of develops in a plan, do, check, act kind of circular fashion. The second process really matches up a solution from the AECC community that may have been done for some other reason than an AECC use case, but it can be readily adapted to solve some of the technical issues for some of the AECC specific use cases. And we implemented a similar kind of a demo showing that this adapted solution really fits the ecosystem and one or more or a category of use cases by having a solution that, quite frankly, could have come from an adjacent industry. We talk about automotive edge computing, but automotive has to exist in the presence of, a billion unit handset market, and so some of the other related applications that might have some impact on mobile edge computing might have emanated, or solutions to other adjacent kinds of markets could be adapted to fit for mobile edge computing as well. And I think that's important to understand under some of the comments made by Krister, that we have to be not just a single solution, single solution provider. Can't be just work with one network, and maybe we can't even work with just one industry. But I think adapting solutions that have come from either other players or other industries that could be adapted for mobile edge computing are just as important for the AECC community. And this second process that I'm describing here is what we call more of a bottom-up process, so that there might be an idea or a solution that's pre-existing that can be adapted to the AECC type of use case. And inevitably, in the AECC's vision of kind of the system of systems concept, we would combine both these top-down and these bottom-up implementations towards a kind of a comprehensive system that combines, solutions from both of these processes and puts together an architecture and a portfolio of services that can be later commercially deployed.
So there's that top-down that is a specific use case, but then that bottom-up where you're looking at potentially something in communications or industry, where there's a lot of IoT devices as well and edge computing, and how that can solve other challenges in the market.
Exactly.
Christy, I just want to add one thing here. I think I completely agree with Roger, and I just want to add that we are also open for doing proof of concepts with companies that is not necessarily part of AECC. And we have examples of such collaborations that we have done before. For instance, we did the proof of concept between Toyota, Ericsson, and Vodafone, which is not part of AECC, but saw value in the technical report created by AECC, and then we together created a proof of concept that showed the value of edge computing, for instance. So these type of relations we also welcome, and we are also looking into how we can formalize that even more. But of course, I mean, if you want to be know all the details and get full insight, you need to be a member of AECC. But that's one way we also encourage the use of the technology that we recommend from AECC.
Great. Good. That's very helpful too. That's good to hear that you're also taking the intelligence and the ideas from outside the network. So certainly the participation in the network, I'm sure, is much more helpful for those members. Right. Any other thoughts? Should I move on to the last question, and then we'll get to Q&A? Okay. So moving on then, we do have one more poll question, and this is one that is definitely more interactive because we'd like to keep the conversation going with you, our participants there in the audience. So for this last polling question, please select how you'd like to keep that conversation going with AECC after this webinar, and you can actually select as many of these choices as you would like. You can receive a recent white paper on distributed computing in the AECC system. So learn more about distributed computing through a free white paper. You can request a meeting to learn more about the AECC. And if you'd like, you can also learn more about AECC membership. So again, I'll give everyone a moment to decide how they'd like to continue the conversation and, discussing more about enabling and really creating a connected car future at its full potential. We definitely need collaboration across the value chain to be able to realize this. We'll give everybody a moment longer. And again, do feel free to choose more than one, A, B, and or C. All right. Everybody, another minute. Great. And again, do listen and share to this recording here with your fellow colleagues. So now we're going to move on to some audience question and answer. So let's go into our Q&A round for today. We've had a really, really great conversation so far, and we'd like to answer some of the questions here that we have in the Q&A. So our first question in the Q&A part here is, how does the AECC differ from other organizations who are looking at 5G, edge computing, and automotive services? And kind of a follow-on to that is, who should join the AECC? So that's a great question. There's other organizations as well. How is AECC different, and who should join?
Yeah, maybe I think it's better to answer from my side. I think the ACC is not really the standardization organization itself, but we are discussing about the future of the technologies, and then we try to evaluate the result of the discussions by proof of concept, and if you find something wrong, then we modify the portions to move forward at the next time. So that kind of technology development organization is a unique point of ACC. So in that sense, of course, the standardization organization must be exist to make a good interoperability across the devices or across the countries or such kind of things, especially in the network portions. But we are just evaluating the technology or solutions based on our own, the use cases requirement, and then try to evaluate it continuously, and then finally create, we generate a set of the system requirements and its best exercises. And then the member company can bring the idea to the each standardization organizations if it's necessary. That's a kind of a role of ACC. And I'm not quite sure the other organization or any other consortium is doing, but I think it's a unique portion, unique point of ACC, I think. And especially for the 5G and edge computing topics, is a very the hot topics in these days. But with regard to the 5G discussions, the many people are trying to find the use cases of 5G, and most of the cases, no solutions to overcome the issues existing to realize that kind of use cases, and that's presenting the use cases or for future possible use cases using 5G only. So that doesn't make sense for us because we cannot move forward without the concrete the solutions. So that's a unique portion with regard to 5G and also edge computing. Many companies nowadays, many companies are talking about edge computing, but sometimes edge computing means edge device computing in the devices. That's in our cases, in automotive cases, it's in a vehicle computation. But what we are trying to do is to make edge computing in the nearest edge of the network to the devices such as vehicle. That means the mobile edge computing or roadside unit computing and so on. The biggest reason why we are putting focus on that is we would like to create a new value and the new use cases using the upstreaming the IoT data from the vehicles and analyze those data to create a new value from that by analyzing in the computers located in the distributed edge locations. So that's a kind of new things, and the concept of edge cloud computing in ACC could be applied for the other type of services exceeded more on automotive use cases. But probably the size of the data generated in the edge device, I mean the vehicle, is more than any other type of devices, and also the value generated from that kind of huge amount of data would be a bit more business point of view. It's a much more value than the other type of business domains as of today, I think. So that's the reason why we put the A. The name of ACC's A means automotive, but we put the automotive before the edge computing in our consortium's name. Is the automotive would be a kind of a leader of leading the kind of new inventions and the innovations using the huge amount of data with the edge computing. So that's kind of things, but we are not limited. We are not limiting the kind of accessibility of our solutions within the automotive, so that it could be applied for the other domains of industry in near future.
That's sorry.
Yeah, that's different. I'm not quite sure what kind of things it's doing in other organizations, but I think I can proud of that kind of the approach of ACC. Thank you.
Sure. So like Roger, no, that's great. Thank you. Like Roger was saying, like you're taking other information from other industries, but also the information and the use cases and the findings from the AECC can be applied to other industries as well. It's kind of a two-way street there. So it's definitely about automotive and about edge, but it's also about so much more, it sounds like.
That's true.
That's great. Wonderful. Thank you. And I do want to encourage everyone to please add your questions there to the bottom, and in case we can't get to all of them, we will follow up with you offline. So again, at the bottom there, you can go ahead and ask your questions, and if we can't get to it, we'll follow up with you. Okay, second question here that we have. Who will own the data generated and connected by vehicle services? And will it be made available for enterprises? Really good question there. So who owns that data? We talk about a lot of data, but that's always on everyone's mind.
You take that, Roger.
Yeah, I can offer an answer here. I think this is sometimes controversial, but nevertheless, we do have to address it. I think the real answer depends on the regional regulations or culture. Some say it's the vehicle owner who bought the vehicle, that data is theirs. Some say it's the vehicle producer who put the systems there to collect the data. And some say it's even the driver in the vehicle. It has nothing to do with the vehicle itself or the owner. It might be a driver, like a rental car. So I can't really answer that question, over a blanket or an umbrella, because it might be different in some regions, as I mentioned. But nevertheless, I think as we've seen in other IoT domains, if you can grant, whoever owns the data can grant permissions for other people to use it, and perhaps even market it in an open and free market. And in order for these kinds of applications and services to effectively operate, those permissions will need to be granted, and the access to the data for public safety, for example, or even some services that might be privatized by either service provider or vehicle producer domain, can be rendered by one or more different parties. So I think the real answer to the question is it depends, and I think everyone in the ecosystem understands that if the data is kept only to one person or one entity, then the system as it's meant to operate won't be very effective, and so therefore there's really not a marketplace for that kind of single owner, single user kind of thing. And so I think everyone in the domain realizes that and understands that the marketplace is there, and that in order to render these services from a commercial standpoint, but also a technical standpoint, that data will need to traverse through many different entities along the supply chain from originator to eventual user.
And really, if you think about it, whether it's the companies providing the services or the partners or even the users, the passengers, the drivers, everyone, we kind of all want the same thing, right? We want the most utilization of that data, which, as you said, involves using data by different parties, but of course with the most security and reliability. So everyone's all very incentivized in the same direction.
Right.
I would think.
And
and
there's a big enough pie. I mean, I think you mentioned it before, Roberta. There's a big enough pie for everyone to have a piece and enjoy it.
Absolutely. Great. Well, I think we have time for one more question here. So thank you, Roger. Appreciate that answer. And how do edge computing and 5G work together in the connected vehicle market? So good question to summarize today's conversation on. Who'd like to take that one?
Maybe I should take that, Christer.
Great. Thanks, Christer.
So you can fill in if there's anything. But no, that's a great question. And working with 5G, I think that we should start to think about what we have talked about in this discussion, meaning that the next generation vehicles will mainly always be connected. They will generate a huge amount of traffic, and some of these services that we talked about will have a very high need and requirement on latency, low latency, and also reliability. And that will vary. There will be different needs and requirements on how you handle it and different ways of monetize on that. And in fact, both edge compute and 5G are means to address these type of topics, and you can't really separate out edge compute from 5G. It is actually a key element of 5G, or what we call distributed computing or distributed cloud. So that, as such, the ability to execute traffic in different places, and as Murat-san mentioned before, in the ACC case, as close as possible to either the originator or at places where it makes most sense, where the data can be managed and computed and stored in the most efficient way and to a low cost. That is very important to manage all this data, because a lot of things we talked about before relate to how can you filter out data, how can you reduce the amount of data before it's sent maybe to the central cloud. That is a big piece of edge. And before I talk more about 5G, maybe we should also remember that 5G also comes with 4G. 4G and LTE is also an important part of 5G evolution, and LTE coverage, so to say, will be needed as a complement to 5G for quite some time, especially in different more rural areas and so on. So if we would say that 4G was the highway to internet for the consumers, 5G is the same for IoT and industry, and we also see that the automotive and connected vehicle industries is one of the most demanding and fastly growing industries requiring 5G. And doing that, as we see now in ACC, the functionality and the mechanisms that we provide they increase in complexity, and therefore, as also talked about, the need for agreement on how to utilize this technology in a consistent way is key for this ecosystem to thrive. Otherwise, we will not have a connected vehicle evolution. So yes, 5G adds a lot of new great functionalities, including edge, but it also handles or adds things for what we call, improved traffic prioritization, traffic routing, multi-session, etc. And this thing with multi-session and multi-traffic is also important for the edge compute to be able to run traffic and execute traffic at different places for different purposes. And very, very shortly then, maybe for those that do not know anything about 5G. 5G, typically when we talk about 5G, we talk about the new radio, which gives you a lot of improvements in capacity and latency and so on. But there are many things in 5G, including things that goes with radio, such as carrier aggregations. You can improve coverage and capacity, sharing spectrums between LTE and NR, the new radio, and also tight interworking between the functionalities or the network functions between 4G and 5G. And that is also, of course, very important then for ACC to make sure that things that we evolve also work or have capabilities in the 4G network. And then, of course, key aspects of 5G is what we call the distributed cloud and network slicing. Network slicing meaning improvement of how you can prioritize traffic. So I think that was a little bit on the relation between 5G and edge.
Great, thank you.
And also the AECC, we can discuss that kind of things from the automotive sectors companies, member companies, and also, the telecommunication sectors companies, and also computation sector companies that are discussing together. That's we can invent something more.
Right, that's a key. To have a problem domain to solve and have all the actors together to look at the problem. Yes.
Great, excellent, thank you, and I appreciate you bringing it back up to bandwidth and latency as well. There, of course, this is one of the things we kicked off on at the very start of the conversation. Well, thank you, everyone. Unfortunately, we're out of time, but if you did ask a question that we were not able to answer on the webinar, we will be following up with you shortly. So do appreciate that, and again, hope that we can continue the conversation through some of those other means that AECC has generously offered, such as follow-on conversations, membership information, and a white paper. So that's all the time we have. If you've missed any part of this webinar, or you'd just like to share it, which we certainly encourage, the on-demand version will be available at Future of Data Connected Vehicles. And you can see that link there on the screen in front of you. So thank you kindly to our participants today. I hope you all have a wonderful day, and thank you for joining our webinar.